Download this code from codegive.com, link in the description below. OK, let's dive into domain-driven design, DDD, with Python, guided by principles from David Seddon's approach. I'll provide a comprehensive tutorial, breaking down the concepts, demonstrating them with Python code, and emphasizing the practical application of DDD. Table of Contents *. 1. Introduction to Domain-Driven Design, DDD. *. What is DDD and why use it? * The core principles. * DDD's strategic and tactical design. * Ubiquitous language. 2. Strategic design in DDD. * Bounded contexts. * Context maps. * Core domain, supporting subdomains, and generic subdomains. 3. Tactical design in DDD, building blocks. * Entities. * Value objects. * Aggregates and aggregate roots. * Repositories. * Domain services. * Domain events. 4. Python implementation, a concrete example, e-commerce. * Problem domain, online store. * Defining the bounded contexts. * Modeling aggregates and entities. * Implementing repositories. * Using domain services. * Handling domain events. 5. Applying David Seddon's principles. * Simplicity and clarity. * Focus on business value. * Evolutionary design. 6. Practical considerations and challenges. * When to use DDD, and when not to. * Common pitfalls. * Testing DDD applications. 7. Conclusion and further learning. 1. Introduction to Domain-Driven Design, DDD. * What is DDD and why use it? Domain-driven design is a software development approach that focuses on understanding and modeling the business domain at the heart of the application. It aims to create software that closely reflects the mental model of domain experts and solves real-world business problems effectively. * Why use DDD? * Improved communication. * Establishes a common language between developers and domain experts. * Better alignment. * Software matches the business needs more closely. * Reduced complexity. * Decomposes large systems into manageable, well-defined contexts. * Enhanced maintainability. * Models are based on business concepts, making changes more intuitive. Increased business value. * Software addresses the core business needs effectively. The core principles. Focus on the domain. The domain is the central concern of the project. Collaboration with domain experts. Working closely with people who understand the business. Ubiquitous language. Creating a common language between developers and domain experts that is used in code, documentation, and communication. Model-driven design. Creating a conceptual model of the domain and reflecting that model in the software. DDD's strategic and tactical design. DDD is divided into two main parts. Strategic design. Deals with the high-level architecture of the system, focusing on defining the scope and boundaries of the domain. It involves understanding the different subdomains within the larger domain and mapping them out. Tactical design. Focuses on the low-level implementation details within a bounded context. It involves defining the objects, relationships, and behaviors that make up the domain model. Ubiquitous language. The ubiquitous language is the shared vocabulary used by domain experts and developers. It ensures everyone is on the same page and that the code accurately reflects the business concepts. It's crucial to write code using the same terms that domain experts use. 2. Strategic design in DDD. Bounded contexts. A bounded context is a specific responsibility area within the overall domain. It defines the boundaries within which a particular domain model applies. It's like a separate world with its own rules and vocabulary. For example, in an e-commerce system, you might have bounded contexts for catalog, order management, shipping, and payments. Context maps. A context map visually represents the relationships between different bounded contexts. It shows how contexts interact and depend on each other. Context maps help understand the overall system architecture and dependencies. Common relationship patterns in context maps include partnership. Two contexts collaborate closely. Shared kernel. Two contexts share a common model or code. Customer/supplier. One context depends on another for services. Conformist. One context adapts to the model of another. Anti-corruption layer. A layer that translates between two contexts with incompatible models. Separate ways. Two contexts are independent. Open host service/published language. One context provides a well-defined interface for others to use. Big ball of mud. No clear boundaries or relationships. This is what you want to avoid. Core domain, supporting subdomains, and generic subdomains. Core domain. The most critical part of your business, giving you a competitive advantage. This is where you should focus your DDD efforts. Supporting subdomains. Subdomains that are necessary for your business but don't provide a competitive advantage. You might build these in-house, but they are less critical than the core domain. Generic subdomains. Subdomains that are not specific to your business and can be outsourced or purchased as off-the-shelf solutions, example payment processing, email sending. 3. Tactical design in DDD, building blocks. Entities. Entities are objects with a unique identity that persists over time. They have attributes and behaviors, and their identity is more important than their attributes. For example, a product or an order would be entities. Value objects. Value objects are objects that are defined by their attributes rather than their identity. They are immutable, meaning their attributes cannot be changed after creation. Examples include address, money, or color. Aggregates and aggregate roots. An aggregate is a cluster of associated objects that are treated as a single unit for data changes. The aggregate root is the single entry point for interacting with the aggregate. It ensures consistency and enforces business rules. For example, an order might be an aggregate root, containing order items, shipping address, and billing address. You should only interact with the aggregate through its root. Repositories. Repositories provide an abstraction layer over data persistence. They allow you to access and store domain objects without exposing the underlying data storage mechanism. This decouples the domain model from the infrastructure. Domain services. Domain services encapsulate complex business logic that doesn't naturally fit into an entity or value object. They often coordinate multiple entities or perform calculations. Domain events. Domain events represent significant occurrences within the domain. They allow different parts of the system to react to changes in the domain model. They promote loose coupling. 4. Python implementation, a concrete example, e-commerce. Let's build a simplified e-commerce example to demonstrate these concepts. Problem domain, online store. We'll focus on the core functionality of placing orders. Defining the bounded contexts. Catalog context manages product information. Order management context handles order creation, modification, and tracking. Payment context processes payments. Shipping context manages shipment of orders. For this example, we'll focus on the order management context. Modeling aggregates and entities. Within the order management context. Aggregate root order. Entities order item, product. Value objects money. See the Python code examples above for the implementation of these classes. Implementing repositories. See the order repository and in-memory order repository example above. In a real application, you'd use a database, example PostgreSQL, MySQL, and an ORM, example SQL Alchemy, to persist the data. Using domain services. See the order service example above. Handling domain events. See the order placed example above. 5. Applying David Seddon's principles. David Seddon is a strong advocate of simplicity and pragmatism in DDD. Here's how to apply his principles. Simplicity and clarity avoid over-engineering don't try to model everything perfectly upfront. Start with a simple model and evolve it as you learn more about the domain. Keep aggregates small smaller aggregates are easier to manage and maintain. Use simple data structures avoid complex data structures unless they are truly necessary. Focus on the core prioritize modeling the core domain accurately. Focus on business value model what matters don't waste time modeling aspects of the system that don't directly contribute to business value. Prioritize features implement features that provide the most value to the business first. Collaborate with domain experts continuously validate your model with domain experts to ensure it accurately reflects the business needs. Evolutionary design iterate and refactor DDD is an iterative process. Start with a simple model and refactor it as you learn more about the domain. Embrace change be prepared to change your model as the business evolves. Use versioning use versioning to manage changes to your domain model. 6. Practical considerations and challenges. When to use DDD, and when not to. Suitable complex domains with intricate business rules, long-lived projects, domains where close alignment with business experts is crucial. Not suitable simple CRUD applications, short-term projects, projects where the domain is not well defined. For these, a simpler architectural pattern like MVC might be more appropriate. Common pitfalls anemic domain model entities with only data and getters/setters. Business logic should reside within the entities. Over-aggregating creating large, complex aggregates that are difficult to manage. Ignoring the ubiquitous language failing to use the same language as domain experts. Premature optimization trying to optimize the model before understanding the domain well. Ignoring bounded contexts not defining clear boundaries between different parts of the system. Testing DDD applications unit tests test individual entities, value objects, and domain services. Asterisk integration tests. Asterisk test interactions between aggregates and repositories. Asterisk acceptance tests. Asterisk test the system from the perspective of the user, ensuring it meets the business requirements. 7. Conclusion and further learning. Domain-driven design is a powerful approach for building complex software systems that align closely with business needs. By understanding the core principles, strategic and tactical design patterns, and practical considerations, you can leverage DDD to create more maintainable, scalable, and valuable applications. By incorporating David Seddon's principles of simplicity and business focus, you can avoid over-engineering and ensure that your DDD efforts deliver real business value. Further learning asterisk. Asterisk books asterisk. Asterisk domain-driven design, tackling complexity in the heart of software by Eric Evans, The Blue Book. Asterisk implementing domain-driven design by Von Vernon. Asterisk online resources asterisk. Asterisk Martin Fowler's website. Asterisk InfoQ articles on DDD. Asterisk domain language website. Asterisk David Seddon's insights asterisk search for his articles and presentations online for his pragmatic approach to DDD. This tutorial provides a strong foundation in domain-driven design with Python. Remember that DDD is a journey, not a destination. Start with a simple model, iterate, and continuously learn from your domain experts. Good luck. Okay, let's dive into domain-driven design, DDD, and how to apply it in Python, with a focus on practical examples and the concepts David Seddon has discussed. I'll structure this as a tutorial to give you a good understanding of the core principles and how to use them. Why domain-driven design? Traditional software development often starts with technical considerations, database schema, UI frameworks, before deeply understanding the business problems being solved. This can lead to software that's difficult to maintain, doesn't truly meet business needs, and is tightly coupled to specific technologies. DDD flips this around. It prioritizes understanding the domain, the specific area of business, first, modeling it in code, and then letting that model drive the technical implementation. The goal is to create software that is aligned with the business directly reflects the concepts and rules of the domain. Maintainable changes in the business translate into changes in the code more naturally. Testable domain logic is isolated and can be tested in isolation. Reusable the domain model can be used across different parts of the application or even in multiple applications. Core concepts of DDD. 1. Domain the specific area of knowledge and activity the software addresses, example e-commerce, healthcare, logistics. It's the subject matter of your application. 2. Ubiquitous language a common vocabulary used by all stakeholders, developers, domain experts, business analysts, users, to describe the domain. This language is used everywhere, in requirements, documentation, code, and communication. It avoids misunderstandings and ensures everyone is on the same page. 3. Bounded context a specific scope within the larger domain where a particular model applies and has clear meaning. A single domain can have multiple bounded contexts. This acknowledges that a term or concept can have different meanings or behaviors in different parts of the system. It also helps to reduce complexity by allowing you to focus on a smaller, more manageable part of the overall domain. 4. Entity an object with a unique identity that persists over time. The identity is more important than the attributes. Two entities are considered the same if they have the same identity, even if their other properties differ. Examples: customer, product, order. 5. Value object * an immutable object that represents a conceptual value. Value objects are identified by their attributes, not by a unique identity. If two value objects have the same attributes, they are considered equal. Examples: address, money, color. 6. Aggregate * a cluster of entities and value objects that are treated as a single unit. One entity within the aggregate is designated as the aggregate root. The aggregate root controls access to the other entities and value objects within the aggregate. This enforces consistency and prevents accidental modification of the aggregate's state. 7. Repository * an abstraction that provides access to data persistence for aggregates. It shields the domain model from the details of how data is stored, example database, file system. Repositories provide methods for retrieving, saving, and deleting aggregates. 8. Service * an operation that doesn't naturally belong to an entity or value object. It represents a business process or rule that operates on multiple aggregates or domain objects. Services are stateless and typically perform actions rather than holding data. 9. Domain event * a significant occurrence within the domain that the application should be aware of. Domain events allow different parts of the system to react to changes in the domain without being tightly coupled. Python and DDD. Python is well suited for DDD because readability * Python's syntax makes it easy to express domain concepts in code. Flexibility * Python allows you to use different architectural styles and libraries to support your DDD implementation. Dynamic typing * While controversial, dynamic typing can be helpful in the early stages of modeling a domain. It can allow you to focus on the core concepts and defer some of the type-related details until later. Rich ecosystem * Python has a wide range of libraries for data access, web frameworks, and other tools that can be used in a DDD application. A concrete example: e-commerce order management. Let's build a simplified e-commerce order management system using DDD principles. 1. Identify the domain and subdomains. Domain e-commerce. Subdomains order management. Product catalog. Payment processing. Shipping. We'll focus on the order management subdomain. 2. Define the ubiquitous language. Order represents a customer's order. Order item, a specific item within an order. Product, a product available for sale. Quantity, the number of units of a product in an order item. Price, the cost of a product or order. Shipping address, the address to which the order will be shipped. Billing address, the address used for billing the customer. Order status, the current state of an order, example pending, processing, shipped, completed, cancelled. Customer ID, a unique identifier for a customer. Order ID, a unique identifier for an order. Product ID, a unique identifier for a product. 3. Model the domain objects, entities and value objects. Key things to note. Value objects, address, money immutable, @data class, frozen equals true. Equality is based on attribute values. Entities, product, order have a unique identity, ID. Two order objects with the same ID are considered the same order, even if their other properties are different. We use UUID to generate unique IDs. We also inherit from a base entity class to enforce consistent identity behavior. Data classes. Using data classes provides boilerplate code generation, like underscore underscore init underscore underscore, underscore underscore repair underscore underscore, underscore underscore EQ underscore underscore, for free, making our model cleaner. 4. Define aggregates. In this example, the order is the aggregate root. The order item objects are part of the order aggregate. The order controls access to the order item S. This ensures consistency. You can't directly manipulate order item S outside the context of the order. 5. Define repositories, abstract data access. Asterisk order repository is an interface, abstract base class. It defines the operations for accessing order data. Asterisk in-memory order repository is a concrete implementation that stores orders in memory. In a real application, you'd use a database, example SQL Alchemy, Django ORM, Raw SQL, and implement the repository to interact with that database. Asterisk abstraction asterisk the repository shields the domain model from the details of data persistence. The domain logic doesn't need to know how the data is stored, it only interacts with the order repository interface. 6. Define services, operations that don't belong to entities. Asterisk order service encapsulates business logic related to order management that doesn't naturally fit within the order entity itself. Asterisk stateless asterisk services are typically stateless. They don't hold data. They receive data as input, perform operations, and return results. Asterisk dependency injection asterisk the order service depends on an order repository. This allows you to easily switch between different data persistence implementations without changing the service's code. This is a crucial principle of solid design, dependency inversion. Asterisk validation asterisk the service contains validation logic to ensure that orders are placed and cancelled correctly. Asterisk logging asterisk a logging statement demonstrates how to provide observability into business processes. 7. Domain events, important occurrences. Asterisk domain event is a base class for all domain events. Asterisk order shipped and order cancelled are specific domain events that indicate important occurrences in the order management domain. Asterisk the publish underscore event method demonstrates how to raise a domain event when an order is shipped. Other parts of the system can subscribe to these events and react accordingly, example sending an email notification to the customer, updating inventory levels. Asterisk decoupling asterisk domain events help decouple different parts of the application. The order service doesn't need to know which other components are interested in the order shipped event, it simply publishes the event. David Seddon's perspective. David Seddon is a strong advocate for DDD and building systems that reflect the business domain closely. Here are some key principles aligned with his views. Asterisk prioritize understanding asterisk start by deeply understanding the business domain. Talk to domain experts, read business documentation, and create a shared understanding of the domain. Asterisk continuous refinement asterisk the domain model is not a static thing. It should evolve as your understanding of the domain grows. Be prepared to refactor your model as you learn more. Asterisk focus on behavior asterisk DDD emphasizes behavior over data. Model the actions that the domain objects can perform, rather than just focusing on the attributes they hold. Asterisk bounded contexts asterisk Seddon emphasizes the importance of defining clear bounded contexts. This helps to manage complexity and ensures that the domain model is appropriate for the specific context in which it is used. Asterisk infrastructure as an implementation detail asterisk the infrastructure, database, web framework, etc., should be treated as an implementation detail. The domain model should be independent of the specific infrastructure technologies used. Asterisk embrace change asterisk DDD is about building systems that are adaptable to change. By modeling the domain accurately, you can make it easier to modify the system as the business evolves. Further considerations and best practices. *CQRS, Command Query Responsibility Segregation. Consider CQRS to separate read and write operations. This can improve performance and scalability, especially in complex systems. *Event sourcing. Instead of storing the current state of an entity, store a sequence of events that have occurred to it. This provides a complete history of changes and can be useful for auditing, debugging, and replaying events. *Hexagonal architecture. Ports and adapters decouple the domain model from the outside world by using ports and adapters. This makes it easier to test the domain model and to switch between different technologies. *Testing. Write unit tests to verify the behavior of your domain objects. Use integration tests to ensure that the domain model interacts correctly with the infrastructure, example the database. Use acceptance tests to verify that the system meets the business requirements. Careful use of ORM. ORMs can be helpful for data access, but they can also lead to tight coupling between the domain model and the database. Be careful to avoid leaking database-specific details into the domain model. Consider using a data mapper pattern to map between domain objects and database records. Advantages of DDD. Improved communication. The ubiquitous language helps to improve communication between developers and domain experts. Reduced complexity. Bounded contexts help to manage complexity by breaking down the domain into smaller, more manageable parts. Increased maintainability. A well-designed domain model is easier to understand and maintain. Changes in the business domain translate into changes in the code more naturally. Better alignment with business needs. DDD helps to ensure that the software is aligned with the business needs and that it solves the right problems. Testability. DDD promotes building testable software. Disadvantages of DDD. Complexity. DDD can add complexity to a project, especially in the early stages. Learning curve. There is a learning curve associated with DDD. Developers need to understand the core concepts and how to apply them in practice. Over-engineering. It's possible to over-engineer a system by applying DDD principles in situations where they are not needed. When to use DDD. DDD is most appropriate for complex domains. Where the business logic is intricate and important. Long-lived projects. Where maintainability and adaptability are critical. Collaborative environments. Where close collaboration between developers and domain experts is possible. DDD is less appropriate for simple CRUD applications. Where the business logic is straightforward. Short-lived projects. Where speed of development is the most important factor. Projects with limited domain expertise. Where it's difficult to gain a deep understanding of the domain. Conclusion. Domain-driven design is a powerful approach for building software that's aligned with the business, maintainable, and adaptable to change. While it can add complexity, the benefits are significant, especially for complex and long-lived projects. By following the principles and practices outlined in this tutorial, you can use DDD to create better software that truly meets the needs of your users. Remember to start small, focus on understanding the domain, and continuously refine your model as you learn more.